So with an absolute value inequality, we're going to build on our skills from section 1.3. And we're going to start by isolating these absolute value bars. And then we'll deal with how to handle the absolute value. So just like before, I'm going to kind of treat this like 2 times the absolute value of some stuff plus 3 less than 11. And for starters, I'm going to like solve this the same way I would solve this. Meaning I'm going to subtract 3 and I'm going to divide by 2. I do want to remind you guys with inequalities, if this number that you multiply or divide by is ever negative, the inequality has to flip directions. But that's not happening here. So we're going to go ahead and kick this off by subtracting 3 from both sides, giving 2 times the absolute value of v plus 5 less than 8. Then I'll go ahead and just like as if I were over here, I'll divide by 2. I'm not going to distribute. That's not how that works here. Absolute value of v plus 5 is then less than 4. And then the worked example tells you some ways to think about this, but I'm going to have you guys think about this a different way. I want you, if the worked example makes sense, go ahead and do that. But if it doesn't, we're going to do this thing called testing regions. We're going to solve this, pretend like this is an equal sign, and just say, okay, either v plus 5 equals the 4, or maybe the v plus 5 equals negative 4. And if I solve both of these things separately, hello, magic pen, please work, we can see that they're equal when v is negative 1 or v is negative 9. So if I put these on a number line, that's a place where the absolute value of v plus 5 equals 4. That's a place where the absolute value of v plus 5 equals 4. Now I'm going to go through and test a number from this region, and this region. And if it makes a true statement, I'm going to shade the entire region. If it doesn't make a true statement, I'm not. So for example, I could pick any number in this region, like a negative 10, or negative 12, negative 20, whatever. I'm going to plug it into this and see if it's true or not. So if I pick like a negative, let's say 20, I get the absolute value of negative 20 plus 5, which becomes the absolute value of negative 15, which of course is 15, and I get the statement 15 is less than 4. Well, guess what? That's not true. So I'm not going to shade this part in. Then I can pick a number from this region, maybe negative 2 or negative 5. Let's go with negative 5. I'm going to do my work down here. So I have like the absolute, let me pick negative 6. Absolute value of negative 6 plus 5 gives me the absolute value of negative 1. That makes 1 is less than 4. That's true. So that means since that negative 6 was true, all these numbers are true. They're either all true or they're all false, because this is the place where they're equal. And then in this region, maybe I'll pick like 0 or a million. Let's say I pick like 28. Weird number to pick. But I can pick anything. So I'm going back to here. Absolute value of 28 plus 5 is the absolute value of 33. Is 33 less than 4? That's not true. So that's not part of my answer. So what I realize is when I'm solving this equation up here, as long as v is between negative 9 and negative 1, not including them, because at negative 1 and negative 9 they actually equal, then I'm good. So my final answer in interval notation would be don't include the negative 9, do include the negative 1, and it's going to be all those x's.